Toxic reactions. We should be able to interpret a chemical reaction and describe what happens in the reaction based on the equation. We should also be able to write an equation based on a chemical reaction, identify reactants, products, as well as phases of matter. Chemical equation describes what's happening in a reaction. We use symbols rather than words. Okay? The basic format of this is the reactants are what we start with, and they form the products. The products are what we end with. Okay? So we have a bunch of reactants. I just put R1 plus R2 plus as many as there needs to be for the reaction, forming the products. P1, P2, however many products there are in the actual reaction. So I use this symbol, the red form. So to form or produce, that's the arrow. It's analogous to the equals sign in a math equation. So what we start with is the reactants. What we end it with is the product. So why we use an equation? So don't write this down. Pay attention. Your eyes should be at the board. So there's a reaction. A solution of hydrochloric acid reacts with a sample of solid zinc, producing an aqueous solution of zinc chloride and gaseous hydrogen. If you had to write that every single time, it would take forever. And a lot of what you actually need to understand would be lost through there's so many words in there. So what we use a bunch of symbols. So hydrochloric acid, we use our chemical symbols. It's like a new language. Remember we talked about this before. 2HCl, aqueous, AQ means aqueous, remember? Plus ZN, solid, S, that's what S means. Forms, that's the arrow. Zinc chloride solution, ZnCl2 aqueous, plus H2G. The G means it's a gas. Okay? This should be pretty familiar to you guys because we talked about this before. So, in the following reaction, you guys are going to want to write this down. The reactants are the substance that the reactions start out as. It's like if I had my Legos and I was going to take them apart to make something else. What I start with would be the original Legos, and what I end with is what I end up with. That's the product. So we start out as the reactants, and I highlighted those in that sort of peachish color. Those are the reactants. It's what's on the left side of the arrow. The products are what the substance is after the reaction occurs. And they are on the right side, highlighted in purple. Moving forward, phases of matter reviewing. This is something we talked about before. S is solid, L is liquid, G is gas, and AQ means aqueous solution. We should already have this down. You don't need to take it down again. But this is just a quick review. The big thing that you want to get is that S does not mean a solution. S is a solid. So it's a common misconception. Okay? Moving forward. When you have the symbol plus, that means if it's a reactant, it means reacts with. And if it's in a product, it means and. The arrow means forms or yields. Okay, so those are two things you want to write. All right, putting it together. So take out your ions and write a reaction for this. What happens is we're going to write a reaction based on this sentence, how we would translate this. So we're going to break it down. Break it down. A piece of solid lead. So how we say a piece of solid lead in a reaction is Pb subscript S. That means solid lead. Reacts with. Reacts with is a plus sign in the reactants. Copper 2 nitrate solution. CuNO3 Aqueous means solution. Forming is the arrow. See? Look at that. Look at that effect. Forming solid copper. CuS, and aqueous lead nitrate, PbNO3 2. So that's how you translate a reaction, word reaction, into a chemical equation. Yes, Griffin.
So when it's forming something,
Yep.
don't you put Cu and NO3 aqueous together? Or is that
No,
no?
because we form solid copper. That's what we ended with, just the element copper. Okay? And lead nitrate aqueous. So that's why they have to be separate. Okay? Good question. Okay? We can also translate reactions, guys. So like this reaction, MgS plus HClAq, arrow MgCl2aq plus H2G. What that means is solid magnesium reacts with hydrogen chloride solution, forming magnesium chloride solution, aqueous magnesium chloride, and hydrogen gas. This took me a long time to do. So that's how we can work on this, and we're going to move on to an activity, and we're going to practice this throughout the year. So let's go back, take a look at our objectives. Hopefully we got all these down, and let's move on to the activity.